Hi everybody, so this is a lesson on elimination, which really works hand in hand with a review of what we have talked about before, which is equivalent equations. So elimination is a method for solving systems of equations like we have here. Remember, systems are two or more equations that are considered together. So if we look at this first example, we've got 2x minus y equals 13 and 3x plus 4y equals 3. Now it's worth mentioning right here that elimination is yet another strategy that we're learning to solve systems. We already know how to use substitution, so this should be something else that we can kind of have in our toolbox when it comes to solving systems. So the first thing, the idea behind elimination is that we're trying to add up these two equations together and eliminate one of the variables in the new resulting equation. So in order to do that, we need to have opposite coefficients for either the x or the y. So we notice right now, coefficient is just a fancy word for the number that's in front of the variable. So for example, we've got on our x's, we've got a 2x, 2 would be the coefficient, and 3x, 3 would be the coefficient there. So negative 1y would be the coefficient on that negative y, and positive 4 would be the coefficient in 4y. So right now, we don't have any opposite coefficients, so our first goal is going to be to make that happen. I'm looking at the top, I'm looking at that negative y, and I'm saying, man, if I could just multiply this times 4, then I would actually have a negative 4y there. And if we follow the rules of equivalent equations, we can totally do that for that top equation. So that's what I'm going to do right now. So what I'm going to do is I'm going to multiply each side by 4, and in doing that, it's going to allow me to turn that negative y into a negative 4y. And I'm going to create an equivalent equation as I do it. So we've got 2x minus y equals 13. And if I multiply each side by 4, that's going to create an equivalent equation. I'm going to distribute that 4, so I'd have 8x minus 4y equals 52. There we go. So 8x minus 4y equals 52 is equivalent. It's equivalent to 2x minus y equals 13. The reason that I want this is because now I have a negative 4y that I can cancel with my positive 4y, and I'm going to show you how that works in a second. So all I'm doing here is I'm rewriting my two equations here, this time just replacing that 2x minus y equals 13 with my equivalent 8x minus 4y equals 52, like so. And now the fun part. We're going to add these up. So we're going to add the terms right down the column. So 8x plus 3x is 11x. Negative 4y plus 4y is 0. And 52 plus 3 is 55. And now we've got an equation that we can very easily solve for x. So we'll divide each side by 11 to undo that. And we actually get that x equals 5. Now that's great, because now that we have that x equals 5, we can kind of use the same method that we were using before with substitution, where we take that x equals 5, we plug it into one of our equations from our system, either these two or the original two, whichever, and we can figure out what y would be. So I'm just going to pick kind of the original up here, the 2x minus y equals 13, because that seems straightforward enough. And I'm going to substitute that 5 in for x. And what that's going to allow me to do, just like we were doing before, is to solve for y. And so I got my ordered pair, 5, negative 3. And that's my solution. Let's give this one a try. Similar situation, right? Our goal here is to try to figure out how we can make these have opposite coefficients. Now, one of the things that's different about this one is that there's not really an easy way that I can turn this 2x into a negative 3x. And there's not really an easy way that I can multiply the negative 3y to equal negative 4y. So what I might need to do is I might need to just pick a couple of these. I think I'm going to pick the x's to eliminate. And we're going to have to multiply something by each of these equations so that when we add them up, we eliminate one of the variables. So I'm going to shoot to eliminate the x's here. And so what I really need to do that is I need a common multiple of 2 and 3. I'm going to go with the least common multiple of 2 and 3, which happens to be 6. So that's going to just allow me, so I need one of those terms to have a 6 as a coefficient, and I need the other term to have a negative 6 as a coefficient for the x. So what I'm going to do is I'm going to give myself a little bit more room here, and I'm going to start with that first expression. So why don't I make that first equation rather, the 2x minus 3y equals 5. So if I want that 2x to be a positive 6, it doesn't matter which one, I'm just going to go with the positive 6. I'm going to multiply each side of that equation by 3, like so, because that's going to get me an equivalent equation. I'm going to distribute the 3. I get 6x minus 9y equals 15. And now I have an equivalent equation that has 6x as the coefficient, which is exactly, or 6 is the coefficient of the x term, which is exactly what I want. Now I need to do the same thing with the 3x plus 4y equals negative 18. Negative 18, 4y there. And now what I need to do is multiply each side by negative 2, making sure I include that in there as well. So now when I go to distribute, I get negative 6x plus negative 8y equals 36. And now I have the equivalent equation here from that bottom equation from the original set. And now what I'm going to do is I'm just going to go ahead and rewrite these on top of each other. So the equivalent to 2y minus 3y was 6x minus 9y equals 15. Underneath that, I'm going to rewrite my equivalent to 3x plus 4y equals negative 18, which is negative 6x plus negative 8y equals 36. And now I can add them up. And again, well, the reason that we're doing this is that we want to eliminate that x out of the system. So 6x plus negative 6x is 0. Negative 9y plus negative 8y is negative 17y. And 15 plus 36 happens to be 51. We divide each side by negative 17. And that gets us y equals negative 3. So we got our y value. And now the real strength here is that since we have the value of one of the variables, it's really easy to figure out the other one, figure out the x, by just substituting negative 3 into either of the equations. And it can be of the equivalent equations or of the original. I'm just going to pick the bottom one from the original. So 3x plus 4 times negative 3 equals negative 18. And now all I have to do is solve for x. So 3x plus negative 12 equals negative 18. Add 12 to each side, and I end up with 3x equals negative 6, and x equals negative 2. So in the end, we've got our x, we've got our y, so our solution here should be negative 2, negative 3, like so. Okay, one more. Let's see if we can figure this one out. All right, this time I'm going to eliminate the y's just to kind of switch things up a little bit. I got a 5 and a 4. There's nothing really easy that I can multiply by one of them to switch it over. So what I'm going to do is I'm going to find a common multiple. And I think I'm going to use 20. So what I need to do is change those y coefficients to 20 and negative 20. I think I'm going to start out changing the top to an equivalent equation. And I think I'm going to change the coefficient in front of the y to a positive 20. And the way I'm going to do that is I'm going to have to multiply each side by 4. So I'm going to do it. So I end up with 8x plus 20y equals negative 28. And voila, there's my equivalent right here. All right, now I just need to do the same thing with the other one. The 3x minus 4y equals 1. Going to have to change this to a negative 20, which is going to require multiplying by 5. So I distribute that, 15x minus 20y equals, oops, I forgot to multiply this side by 5 as well, equals 5, like so. So here's my equivalent down here. So now I'm just going to rewrite my equivalent equations on top of each other. 8x plus 20y equals negative 28. And 15x minus 20y equals 5. Add these up. Negative 28 plus 5 is negative 23. The 20 is 20y plus negative 20y is 0. 8x plus 15x is 23x. And what we're going to do is get x equals negative 1. So we got one of our variables using the elimination method. Now I just need to plug this into one of the other equations. I'll pick the top one. You can pick whichever one you want, but I will just substitute negative 1 in for x on that top equation of the system. And solve for y from here. And I got y equals negative 1, so it looks like the solution to this set is negative 1, negative 1. Give these a shot with the problems A and B.